Hello everyone, welcome to the channel. In today's video, we are going to understand one of the most powerful machine learning algorithm, support vector machine, commonly known as SVM. If you have ever wondered how Gmail detects spam email, how hospital classify disease, or how banks detect fraud, then SVM is one of the algorithms that can help solve these problems. By the end of this video, you will understand what is SVM, how does it work, what is a decision boundary, and where is SVM used in the real world. So let's get started. First question, what is SVM? Support vector machine is a supervised machine learning algorithm. The word supervised means the model learns from labeled data, as we know. For example, suppose we have images of cats and dogs. So each image already has a label, cat and dog. The algorithm studies these labeled examples and learns the differences. Now, when a new image comes, so SVM predicts whether it is a cat or a dog. So SVM is mainly used for classification, regression, and outlier detection. These are the three headings: classification, regression, outlier detection. However, it is most powerful or popular for classification problems. Now we are understanding the image. Low something we are understanding. So let's understand the figures shown on the screen. Imagine these red dots represent one class, for example, spam emails, and the green dots represent another class, for example, genuine emails. So our goal is to separate these two groups. The black line shown here is called the decision boundary or decision plane. The line divides the data into different classes. When a new email arrives, the algorithm checks on which side of the line it fails. Sometimes we can say the algorithm checks on which side of the line it falls. So if it falls on red side, it predicts spam. Sometimes it is known as spam area. If it falls on the green side, it predicts not spam. Simple. Real life example we are taking. Let's take a real world example. Suppose a bank wants to detect credit card fraud. The bank has historical transaction data. For each transaction they know amount, number one, number two, location, number three, time, number four, device used, whether it was fraud or genuine. So using these labeled data, SVM learns the pattern. Now imagine someone suddenly spent 2 lakh rupees from another country at 3 a.m. This transaction looks very different. So SVM places this new transaction on the feature space. If it fails near the fraud region, it predicts fraud. Otherwise, it predicts genuine. This helps banks stop fraud in real time. Why it is called support vector machine? Now, you might ask, why is it called support vector machine? So it's a good question for everyone. Not every data point is equally important. Only a few data points that are closest to the decision boundary decides where the boundary should be. These important points are called support vector. Think of them as the players who decide the final result of a match, even if many other data points change slightly. The support vector remains the key points that determine the boundary. We are taking some advantages and application of support vector machine. So few advantages of SVM are: number one, works well with small dataset, number one. Number two, provides high accuracy. Number three, handles high dimension data efficiently. And number four, effective in text classification and image recognition. So some other applications of SVM like face recognition, we are saying facial recognition, medical diagnosis, spam detection, handwritten recognition, fraud detection, cancer classification, bioinformatics. So let's quickly revise. Support vector machine is supervised learning algorithm and it learns from label data. Its main objective is to find the best decision boundary that separates different classes. The closest data point to this boundary are called support vector and they play the most important role in building the model. So finally, if you found this video helpful, do not forget to like, share and subscribe to the channel. Thank you for watching and I'll see you in the next video. Bye bye.